Hello, welcome back. We were saying here that when adding or subtracting, when adding two measurements, we should always look at the measurement having the fewer digits to the right of the decimal point. So when adding or subtracting decimals, the answers must have the same number of digits to the right of the decimal point as there are in the measurement having the fewer digits to the right of the decimal. So when you compare the two, as we have discussed already, then we would have 25.1 gram being considered and not 2.03 gram, which is having more of the digits in the right of the decimal point. So it has only one such digit. So following the rule, the answer had to be rounded off to 27.1 gram. So when working with whole numbers, the answer should be rounded so that the final significant figure is in the same place as the left most uncertain digit. This should be noted too. So let me write it here because you have to note this when working with whole numbers. The answer should be rounded so that the final significant digit is in the same place as the leftmost uncertain digit. At the leftmost uncertain digit. For example, if we are having 5,400, so we said the answer should be rounded so that the final significant digit is in the same place as the leftmost uncertain digit. So the leftmost uncertain digit in this instance will be here. So let's try and see if we are adding this to 365, we would have got 54365. But we are supposed to round it to the leftmost uncertain digit, which in this case is the digit 4 here in this number. So we will look at this. This is less than 5. So the answer here would be the answer is 58. 58. So how did we do this? So you can see, if you are rounding this or the most uncertain, this looks very complicated. But that is the rule. If you add these two digits, sorry, I made mistake here. This is supposed to be 5,400. So we will redo this part here. Should be 5,400 plus 3,600, 350, which would give you 5,800. So if we are to add directly here, this is what we would have. We would have 5,765. So we are supposed to round it to this digit here. So we end up with, looking at this is more than 5. Therefore, we make this 8. So we have 5800. So these are the significant figures, and this is the most correct answer. So multiplication and division with significant figures. The next thing we are looking at here is multiplication and division of significant figures. And division of significant figures. So we want to see what are the rules when you are carrying out multiplication. So suppose you calculated the density of an object that has a mass. So if you are given mass to be 3.05 gram and volume to be 8.47 milliliter. The division for this number on calculator would be, because if we are calculating density here, density, you know, it is equal to mass divided by volume. So we are having here, solve for density, would give us 3.05 grams divided by 8.47 milliliter. This would be 3.05 divided by 8.47. We would get 3,600,000. So the answer must be rounded off to the correct number of significant figures. The value of the mass and volume used to obtain the answer have only 3 significant figures. As you can see here, we have 1, 2, 3, 1, 2, 3. So the answer must be rounded to the correct number of significant figures. The value of mass and volume used to to obtain the answer have only 3 significant figures each. So the degree of certainty in the calculated result is not justified. If we are using the number here, then it would not be justified. It would not be justified. So for multiplication or division, the answer can have no more than significant figures than R in the measurement with the fewest number of significant figures. So that is another rule. For multiplication and division, the answer can have no more significant figures than R in the measurement with the fewest number of significant figures. So we will be looking at the fewest number here of significant figures. This has 3, this has 3. For this case we have 3, there is no problem. But so in the calculation we just described, we had 0.360094451 gram per milliliter. This would be rounded up to 3 significant figures to match the significant figures in both the values of the two numbers. So the answer would be, this is significant up to here, the answer would be 0.360, and this should be grams per milliliter. So this would be the correct answer for that. Conversion factors and significant figures. Conversion factors and significant figures. So earlier in the chapter, we learned how conversion factors are used to change one unit to another. So such conversion factors are typically exact. That is, there is no uncertainty in them. For example, they are exactly 100. There is no uncertainty. There is 100 mirrors in a meter. There is no uncertainty in this. So if you were to use the conversion factor 100, if you were to use the conversion factor here, 100 centimeter divided by a mirror, to change mirrors to centimeters, the 100 will not limit the degree of certainty in the answer. Thus, if we want to convert, for example, if we have 4.608 meter, this could be converted to centimeters as follows. So we would have this, we would have here 4.608 meters multiplied by 100 centimeters divided by meter, we would get 460.8 meters. Sorry, centimeters. So this would be centimeters. So the answer still has for significant figure because the conversion factor is considered exact. So the answer would not be rounded. Most exact conversion factors are defined rather than measured quantities. So most exact conversion factors are defined. They are defined rather than measured quantities. So because they are defined, they don't change. They don't change the number of significant figures. Here we have 1, 2, 3, 4. 1, 2, 3, 4 significant figures, and this would remain. So there is no uncertainty here. So when you are dealing with conversion factors and significant figures, there is no need of you trying to make estimates. Trying to round off, because normally the most exact conversion factors are defined rather than measured quantities. In the next unit, we will be looking at scientific notation and how it is used to express very large or very small numbers. We will stop here for this video.